Good morning, everyone. Dear authors and invited guests, it is my great pleasure to welcome you to the 6th International Congress on Information and Communication Technology through this platform, Zoom, on behalf of ICICT 2021 and Global Knowledge Research Foundation. As every one of us is passing through unseen conditions due to COVID-19, we wish everyone and their families a safe time. Further, with immense happiness, I would like to share with you that we received an overwhelming number of papers this year from across 90 countries, where 1,150 papers were received and 350 papers were accepted, contributing to the success of this conference. And the papers will be published in 4 volumes this year. We are thankful to all our guests present on this platform to join us digitally for the conference in these unpredictable times and make this conference more fruitful in terms of technical knowledge, and hope you will enjoy the 2 days of the knowledgeful and interactive sessions. I would like to welcome you to this technical session 4E and further introduce all to the chair for this session, Dr. Katarina Moreira, who is a lecturer and a researcher at the School of Information Systems, Queensland University of Technology. Her research is mainly focused in developing alternative decision support systems that can deal with uncertainty using the mathematical principles of quantum mechanics. The main advantage of these frameworks is that they can accommodate human paradoxical and irrational decisions, which can be very useful not only for cognitive systems, but also for decision-making systems that deal with human data. She is also interested in the development of new algorithms and methodologies for the application for machine learning algorithms with responsibility by providing the user meaningful explanations about the underlying mechanisms of machine learning predictions. So welcome everyone, and we can commence our this session by a presentation by Dr. Renee Painel, who will present presence in VR experiences and empirical cost-benefit analysis. Dr. Renee, the floor is yours.
Yes, Rennie, I have just made you the co-host. I think now you can mute and unmute yourself. Yes.
Yeah, thank you very much. Good morning from Germany. Thanks for the introduction. My topic is presence in VR experiences. We've conducted an empirical cost-benefit analysis, and I'd like to briefly walk you through what we've done. So in general, our goal is to look for factors that allow for as much immersion in virtual reality experiences as possible. And we're looking both at technical aspects and content aspects. And in this analysis, we've mainly concentrated on the content aspects. First of all, we need to distinguish between presence and immersion. So presence is more or less what the user perceives, how strongly he feels or gets the immersion, the illusion of being in the different place that he sees, and not so much in the real physical place where he actually is. And in contrast to that, immersion is called the objective characteristics that the amount of immersion that the technology can provide. So things like the screen resolution or the absence of the screen door effect and things like that, that allow for presence feeling of the user. So they are more or less the base for presence feelings of the users. And we've concentrated on the presence in our study. We've also looked at related work, of course, and we found out that many of the related work are not using the currently well-established consumer headsets for virtual reality that can be bought, but concentrate on research prototypes or use very expensive cave environments. And also, we didn't find a study that concentrated on the cost-benefit ratio. So there was a lot of literature on the factors that contributed to presence, but none that also took the cost or the effort to establish that amount of presence into consideration. So that's where our study comes in. So our target group are SMEs that try to establish virtual reality experiences to replace or accompany existing possibilities to show their exhibits to the possible customers. And we're looking especially at kitchen or bathroom exhibitions and virtual tours for museums, real estate sales, and things like that. And for those companies, it's of course a large factor whether it's very costly or very much effort to establish a certain virtual reality experience, or whether it's done in a few minutes, so to speak, and whether you need to invest a six-digit amount or whether it's enough to buy a cheap consumer headset. And in our tests, we were using HTC Vive Pro on a decent gaming PC, and we are using Unity together with the Steam VR plugin to show the virtual reality experiences. For the empirical study, we gathered 28 candidates and thought to have a good differentiation in age and also between genders and between experienced VR users and beginners. And we assembled questions from the literature that were useful for our study, and grouped them accordingly into the 4 categories that we were testing. Examples for questions that we were asking were: how natural did it feel interacting with the environment? How convincing was the feeling of moving around in the virtual environment? Or how accurately could you visually examine the environment? And we conducted studies in 2 different scenarios. So the first scenario dealt with the question whether 360-degree images were better suited, or whether you need a 3D model. And you see here an example of a 360-degree image, of course in a flat way here. And we tried to build that or rebuild that environment in 3D, and the result looked like that. So it's not directly identically as you see, but close, so that the similarities are quite visible. And then we asked the people to experience those settings in VR. First of all, we tested which impact the visual quality has. So higher resolution images led to better presence feelings, what we already thought would be the case. And also stereo images to have a 3D effect on the user also led to higher presence feelings. That was also expected. But on the other hand, what we did not see up front was that some users reported about higher problems with nausea if they had the 3D images, because if you're moving and the surrounding is not moving with you, because that's one of the restrictions of 360-degree images, then the brain causes nausea for some people more than for others, and with the 3D effect, this feeling is stronger. So therefore, this is not always a good idea. And then we were comparing the 360-degree image scenario with our 3D model. And we expected due to the lower visual fidelity of our 3D model, that the 360-degree images would be perceived as with a higher presence feeling than if we constrain the 3D model to 3 degrees of freedom, so to make it similar to the 360-degree images. But that was not the case, so we could not confirm that hypothesis. But if we relieve that restriction to 3 degrees of freedom and have 3D models with full 6 degrees of freedom, then they were found to lead to much higher presence than the 360-degree images, which we already assumed upfront. And then we had a second scenario, which has a lower visual fidelity, as you see, to concentrate on the interactivity aspect and the effect on presence here. So we presented the people with this scenario, which resembles a living room. And the task was to count the number of books with the title Virtual Reality that were scattered around the room. And we had different interaction possibilities that are displayed here in a graphical way. So depending on the scenario, you could open the drawers, look inside the cupboards, and take books from the bookshelf and things like that. And we had 3 different versions, all in the same scenario. One where you could only look around and cannot take or grab anything. Then version 2 with simplified interaction, which means that you can simply push a button and the book is in your hand, and push the button or relieve the button, and then the book automatically gets back to the previous place. Or a more natural interaction in version 3, where you really have to grab the book and it behaves physically correct as far as it's possible inside the simulation. So if you drop it, then it falls to the floor, and you can grab it from there again. You can, it's not automatically returned somewhere. And the hypothesis was that simplified interaction would be perceived better than the scenario without any interaction possibilities. But we could not support that hypothesis. So there were no significant differences in the presence feeling with simplified interaction and no interaction by just looking around. On the other hand, we had a strong preference of users for the scenario with natural interaction capabilities compared to the simplified interaction possibilities. And it turned out that the natural interaction was even easier to achieve with the tools that we were using, because the Steam VR plugin provides you with everything that's necessary to easily get things like opening a drawer, that's called linear drive, or for opening a door in a cabinet or a cupboard, that's called circular drive. And that's quite easy to establish without a large need of programming or things like that. So finally, we resembled...
We have 2 minutes left.
Yes, that's the
okay.
two slides only left. Thanks for the reminder. So we resembled this table where we tried to show the effort that is necessary to establish a certain level of fidelity. And of course, you cannot generalize that very easily because it's depending on the competencies of the person that compiles the 3D scenario. But we found that this is a good rule of thumb that you can use for estimating how long you need to establish a certain 3D scenario. And as an outlook, what we are currently doing is to look at scenarios with higher visual fidelity and even more interactivity. So in this kitchen scenario, or combined kitchen and living room, you can literally use everything that's lying around. So you can grab anything, you can throw it around. The water is flowing, you can turn on the oven, you can look into the refrigerator and things like that. And we like to find out whether this makes more or creates even higher presence feelings than in the previous scenario with low visual fidelity. We also included sound and try to test different controllers that allow for different haptical experiences. So that's what we are currently working on. Thanks for listening. Finally, we have the literature. So I'm finished with my presentation.
Thank you. Thank you for your presentation. And any questions? Okay, then we move on to Dr. Ralph Christian Harting will present potentials of digital business models in the construction industry, empirical results from German experts. The floor is yours. Just a second, I will ask the co-moderator to give you to make you the co-host.
Yes, just a minute.
Dr. Ralph Harting.
Yeah, I'm doing it.
All right.
Yes.
I guess you can unmute yourself.
Now you can unmute yourself.
Yeah, now it's working. Okay, can you understand me?
Yeah, we can hear you well.
Okay, Mohammed, thank you. Yeah, thank you for being here. My name is Ralph from Aan University. There I'm working in the department business science, and I'm professor for information systems. And my topic today is about potentials of digital business models in the construction industry. It's a long-term survey we did in the last 2 years. And we investigated different industry sectors. And one of, I think, one very interesting industry sector is the construction industry. So I'm gonna share my slides with you. All right. Yeah. Construction industry, as mentioned before, is all over the world a very important industry sector, and of course we have a couple of impacts also in this industry sectors driven by digitization. And digitization, in our understanding, is intelligence business and value creation process, and of course the usage of communication technologies. Specifically, when we are talking about digitization, digitization, we are thinking about using big data, cloud computing, mobile computing, Internet of Things, and social software. These drivers are, in our opinion, most important for digitization. Yeah, and we investigated the impact on of digitization on business processes and business models. And of course, there's also a difference between the two wordings. Business processes means a logical linked chain of sub-processes adjusted to the achievement of a specific goal. No? And business models means a method how a firm can develop new business, which bring the firm to new revenue potentials. Yeah, we established we identified two research gaps. And the first gap is that recent research has not confirmed so far the main driver of how to benefit from digital business models and digital business processes in many industry sectors, and of course also in the construction industry. And the research gap number two, there is no scientific evidence how these influencing factors on the potentials interrelate to each other. So that was our main focus on these two gaps, and we rolled out our empirical survey. So in the first step, we defined theoretical constructs based on a literature review. It was a structured literature review. So we used high qualified literature ranked in well-known journals and conference proceedings. So the minimum standard was for each hypothesis an C-ranked journal or conference proceeding. And yeah, and based of building these constructs, we used quite sophisticated methodology from empirical research, structural equation modeling. That was our approach, yeah. And finally, we interviewed experts with focus on IT management and project management in the construction industry. Within German-speaking countries, not only Germany, also we interviewed also experts in Austria and Switzerland. Of course, all of them had an expertise in digitization, or better to say, in aspects of digital business models. So here on this slide, you see our constructs. We based on 20 items, in other words, indicators we identified within our SLR, as a structured literature review. We formulated 4 constructs, in other words, determinants. So, based on these constructs, we investigated the relationship between the independent variables on the one hand side and the dependent variable, the potentials of digital business models and processes. The survey was rolled out in 2019 and 20, and finally, the final size of the sample is 102 after data cleaning. And of course, we eliminated all data which were not fully answered, or where we identified some other mistakes. And as mentioned before, for getting the results, we used a structural equation modeling approach. It's a multivariate analysis of the second generation. And you have the advantage that you have two models, the reflective model and the measurement models. And based on these two models, you can investigate your research question. Yeah, and we use different properties, psychometric properties, to judge the reliability of our results. We used Cronbach's alpha, the AVE, and the composite reliability to find out how does the measurement model works. Yeah, and first of all, I want to start with some descriptive results. So half of our enterprises are small and medium-sized enterprises we investigated. 92 of the experts have been working on digitization for at last 1 year, or even more, of course. And here on this slide, you see the results based on our structural equation modeling. And we use structural equation modeling is using different tests, and one is the t-test, and you can see two constructs which have a significant relationship to our dependent variable potentials of digital business models and processes. Yeah, here you see the results in a table. The pass coefficient, then the p-value, and the three psychometric properties I mentioned before, to measure or to give an idea how does the measurement model works. Okay.
We still have 2 minutes.
All right. I'm almost finished. Coming to the conclusion, the study depicts 4 constructs. Key performance indicators is one, the other one individualization, efficiency, and the last one is communication, reflected by 20 indicators. 2 of them have a positive impact on our dependent variable, the potentials of digital business models. In our understanding, our research shows an increment value for science is the new measurement model and scales with good to moderate quality criteria like AVE, composite reliability, and Cronbach's alpha. Yeah, from a practical perspective, we have various advantages by implementation of digital business models. The reduction of transaction costs could be an advantage, and improved management of large data amounts, a possible reduction of labor costs, etc. Managers and entrepreneurs in the construction industry can profit from our research by using the results to focus on the main potentials with respect to their own business. Yeah, and finally here we have some limitations. Of course, the sample size. I think it makes sense to enlarge the sample and also to other locations outside from Germany, Austria, and Switzerland. And yeah, the future research from our side is to investigate other industry sectors and to compare the results among different industry sectors, this focus on digital business models and digital business processes. Okay, that was my last slide. Thank you very much. And I'm open for questions.
Thank you. Thank you for the informative presentation. Any questions? Okay, then we move on to Dr. Jayashree Gorbadi Aher will present effective feature selection using ensemble techniques and genetic algorithm. And the floor is yours, Dr. Jayashree. You can unmute and share your screen.
Is it visible? The screen is visible?
Yeah. Yes, we can see.
Good morning, everyone. Myself, Jayashree Gorbadi, and my other supervisor, Dr. B.H. Kamble sir. I am doing my research from PICT, Pune, SPPU University, Maharashtra, India. I would like to thank the ICICT 2021 committee for giving me the opportunity to present my research. So the research topic is effective feature selection using ensemble techniques and genetic algorithm. This is the outline, the introduction, related work, proposed methodology, experimentation results, and conclusion. So today, feature selection plays an important role in each and every machine learning model in different aspects. Actually, we are moving from the procedure-oriented approach to data-driven approach. So selecting the features which are more susceptible to the changes in data is again a challenge for today, because to have the consistent result is very important. If we use single method process analysis, then we may have the weak predictions. Thus, there is a need to have efficient techniques for estimating the feature relevance. In the current pandemic, we have seen that the mortality rate has increased, and it's nearly 10% as per the results which were given by one of the references for William Harry Hospital, UK, with most of the patients which are diagnosed with diabetes. And this is something which is associated with diabetes 2 type of mellitus. So the objective for the research was to analyze and select features from heterogeneous data by using feature selection techniques with the ensemble approach and genetic algorithm. The related work. When we have the relevant features, it is very important and plays a crucial role for analyzing the data. So as per the related work and the literature review which was done, few of the important points were such as removal of redundant features will avoid incorrect decisions. Then even this will avoid the overfitting problem, because whenever we have the data, we divide the data into training set and testing set. So it may happen that the result for training set may be good, but when it comes to the unseen data, for the testing data, overfitting problem is a challenge. Minimizing the misleading data will definitely help to improve the performance of the model. Less the data with the significant relevant features, we will even have reduction in the complexity of computations. Thus, the reduction time will also be reduced, because when we have the training data, and training the data will fasten the process of modeling. Single technique of feature selection hardly gives the optimal features or maybe the effective features. And that is the reason if we go for the ensemble approach, having multiple feature selection techniques, this will help us to have the robust system. So different techniques were studied, univariate techniques, multivariate techniques. So most of the statistical techniques such as the chi-square method is there, information gain method is there, ROC scores. These were related to the univariate techniques. In multivariate techniques, where we actually have the bagging and boosting type of algorithms, then random forest is there. So that was one approach considering the related work. The research gap identified thus was to design a technique for estimating the feature relevance, to have the more specific and effective features which will contribute towards the outcome variable. Feature selection technique with efficient feature subset will definitely help us because we'll have reduced number of feature subset, ensuring the robustness and stability of the technique by having multiple base selectors. So that there's where the proposed methodology comes into picture. So this was the ensemble bootstrap genetic algorithm. This is the name given to the proposed methodology algorithm. Now, as you can see, initially we have the data set. We perform the data pre-processing, then removal of the null values, removal of the redundant data, feature creation, feature engineering. And as you can see in the block given here, actually we are applying the ensemble approach. So different multivariate and univariate selectors were taken as the algorithms. We had the data that was divided into sample. So that was the bootstrap sample method. Applying the ranking or order, considering the scores, and then the ensemble approach. Now here again, one important challenge was the aggregation of the weights. So for that purpose, we have used the arithmetic mean. And finally, the optimized K result was given to the genetic algorithm further to have the reductions. So basically this algorithm is divided into two parts. So the first one is selecting the top K features, and the second part is giving these top K features to the genetic algorithm for the optimization purpose. So as you can see, we have the data set D, which can be divided into bootstrap method. So here I had considered the 6 slots were considered, D1 to D6. And for each and every bootstrap which was given, the feature score was calculated for that particular feature set. Then the ranking was done, but obvious it was in the descending order to get the most significant score of that particular feature. Aggregation was done, and the K set, that is this FK, the top K features were generated. Now, these top K features were again given for calculating the further efficiency to the genetic algorithm. So initializing the population, considering the fitness function. This fitness function, we had considered the accuracy score for each and every feature. While then considering the mutation and crossover purpose, we could get the fittest individuals. And in the next run, then this fittest individual was given as an input. So in this way, we could calculate the efficient features out of the top K features. And further, the accuracy measures and performance metrics was calculated. Now, the experimentation, as we had just seen, everyone, we are there with the pandemic situation, facing the COVID-19, taking precautionary measures for our healthcare. So as per one of the report by Center for Disease Control and Prevention, the mortality rate was 7%, but this was around Jan 2020. As per the recent survey which I have done, as August 2020, World Health Organization, nearly 422 million people are having diabetes. So the mortality rate with the diabetes patient is increasing. So this was one of the reason and motivation to go for the type 2 diabetes mellitus disease. So here the publicly available data set, electronic health records has been considered. Now, considering the diagnosis purpose, now this diagnosis dataset is based on ICD-09. ICD is International Classification of Diseases, and that is something which is actually available in the US Department of Health and Human Resources. So total 38 features were there, and out of which, after doing the performance analysis and feature analysis, we could get 5 effective features. So as you can see, this is the table giving the feature analysis with their scores. And the last column is the one which is used for the aggregation purpose: cardiovascular, genitounitary, endocrine, hematology, and musculoskeletal. So if I've seen in the figure, after doing the analysis, people having cardiovascular disorder as one of the disorders are more susceptible to have diabetes 2 type of disease. So if you could see the first row, 0.46, and the second one is having the disease plus the diagnosis diabetes. So nearly, as per the calculations done for this from this table, nearly 37.54% of people are susceptible or are more likely to have the disease. So these are the remaining disorders which are analyzed, performing the same analysis studies. Now analyzing the scores. So initially, like as there were 38 features, I tried it with different classifiers: decision tree, gradient boost, KNN, linear regression, random forest. So considering first 10 features, then K is equal to 20, next 20 features, K is equal to 30, and the dark blue color is the one which is there for the proposed method, the results for the proposed method. So we could see that more of the consistency was there with gradient boost type of classifier. This was another data set which was again considered, that was related to transcripts of those particular patients. So here also, when the analysis was done with different values of K and the proposed method, it was seen that gradient boost was more useful, giving the constant results. Now, here comes the comparative performance analysis, considering the features with I decided to go for the gradient boosting as the classifier. Now, after having this, just using the top 10 features, the accuracy was 80.55%. Whereas giving further as an input to genetic algorithm, it was increased. So now it was 80.65. Even the precision was improved, and the classification table which we have, considering the confusion matrix, the true positive values were increased. So the precision was increased. So as you can see in the ROC curve also, I could have a better model with the value of 76%.
We still have 2 minutes.
Yes, thank you. So here, after considering the analysis with the existing techniques also. So the first one is one complete data. You're giving the complete data as it is to just one technique, as I mentioned. Then in the second way, we are giving bootstrap, one technique with one algorithm only. Whereas the proposed method, the dark blue color is the one with the proposed method. So here we are bootstrapping the data and giving it to multiple classifiers. So we could have a robust system. So I would like to conclude that the analysis of the data was performed by using the ensemble bootstrap genetic algorithm feature selection method. We could get effective features using this with the ensemble technique to provide robustness and select effective features. So as the example considered over here for diabetes 2, if we could get the risk factors like cardiovascular, we can have the measures and we can reduce the mortality death rate in this pandemic. These are the references. Thank you so much. Yes, I have done.
Thank you for your presentation.
Thank you.
Any questions?
Thank you very much for this talk. It's very interesting to see that, again, feature selection is always that process that we should always take into consideration in order to optimize a machine learning algorithm. One thing that I'm curious in, I think it could benefit a little bit your research is, so one thing is we are selecting important features. And again, this is all a game of optimization. The machine learning algorithm, what it does, it tries to minimize a cost function based on the data and the parameters that you have. Now, one question is these features that you selected, these are for the entire machine learning model. An interesting thing that one could investigate based on this approach, and then you could compare with other different models, is whether these features that you selected are actually relevant when you are trying to understand for single instances what are the most important features. So one thing is the global features that are from this machine learning algorithm. Another thing is what are the most important features that are locally important. So if I have diabetes, the machine learning algorithm will tell me yes, for instance, will classify as yes.
Yeah.
But for instance, another person might either have diabetes and the black box might classify as yes for a different reason because of a different feature. So I think it would be really interesting if you could extend this approach of yours and see if the features that are locally being detected for a local specific instance do actually make sense or actually are relevant for the domain that you are analyzing in that instance. Because again, the algorithm is always minimizing cost function. It can say yes or it can say diabetes, but not for the correct reasons. So I think this is really interesting work and would benefit a lot with this additional local instance-based analysis of feature importance.
Yes, sure. I'll consider that and considering the future enhancements also. So actually, when giving it to the second optimization algorithm, the cost function is also increasing because we are trying to have more relevant features. So even the false positive, as you said, one may have cardiovascular, which is the most affected relevant feature, or other person is having he's detected yes, but maybe some because of some other feature which is there. So false positive part which is there. So currently I'm working that also. Definitely, thank you so much for the inputs also.
Yeah, and again, that can also be very interesting again to try to, because your feature importance can also tell the user if there's some bias or not in the data. For instance, the feature is detected as being relevant when it shouldn't make any sense in that context. So yeah, I think it would be very interesting to extend on that.
Yes,
path.
yes, I'll do. Thank you so much. Thank you, everyone. It's done.
Thank you for the comments. Thank you. Now we move on to Dr. Youssef Ibn Atta, will present exposure and evaluation of different indoor localization systems. Dr. Youssef, the floor is yours.
Hello?
Yeah, hi. We can't hear you.
Okay.
Still. We can see your slides, but still we cannot hear you.
Can you see my screen?
Yeah.
Okay. I present myself. Ibn Atta Youssef, PhD student at National High School. I have a master's degrees in mechatronics. I work on indoor localization system. For the exposure and evaluation of different indoor localization system. In this presentation, I'm going to start the exposure and evaluation of different indoor localization systems. For the agenda, I will start with introduction, the major constraint of indoor positioning system, evaluation criteria for indoor positioning system, exposure of the different indoor location classes, evaluation of indoor positioning system, and I will finish with conclusion and future works. For the introduction, indoor localization attracts a lot of attention because people spend their maximum time indoors. Further, the loss of GPS signal power through tours, which require the integration of another approach to locate passengers indoors. There are many approaches presented in the literature, but they suffer from more constraints. For example, multipath effects, instability effects, penetration effects of radio signal.
Dr. Youssef, we lost you.
Hello, Yusuf.
Can you see my screen?
Yes, we can hear
this
you.
table presents the major constraint of indoor positioning. Okay. This table presents the major constraint of indoor positioning system. For example, pedestrian based receive senior strength suffer from multipath instability and penetration effects and card constraints. For Bluetooth suffer from multipath penetration effects and card constraint. For radio frequency identification suffer from penetration effects. For triangulation suffer from multipath instability. For UWB system suffer from penetration effects, instability, interference signal interference. And for the ZigBee protocol suffer from instability, penetration effects. For ultrasound suffer from multipath instability and penetration effects.
We have some technical issue. So by the time the issue gets solved, we can move the next presentation. We will allow him again to present. That would be better.
Then we will move on with Dr. Youssef El-Mdari, who will present Casablanca Smart City Project, Urbanization, Urban Growth, and Sprawl Challenges during Remote Sensing and Spatial Analysis. Dr. Youssef, the floor is yours.
The co-host.
Yeah. Now you can unmute yourself and share your screen, please. Okay.
So Can you hear me? Can you see me?
Yes, we can hear you and we can see your slides.
Okay. I will try the full screen if it's working. Is it working?
Yes, it is.
Okay, so let's begin. First thing, I want to thank you and for this opportunity. I'm very pleased to share my work with you. And the work that I will be presenting today is called the Casablanca Smart City Project. It's a project that is been launched in Casablanca in order to make a city, smart city, but it's faced many challenges. The main ones are urbanization and the urban growth and sprawl. And I do this analysis and this work based in remote sensing and spatial analysis. So the presentation plan will be as so. We will speak about history of Casablanca and the study context, the study area, a Casablanca Smart City project, the data that we use, the methodology, results and discussion, conclusion, and the future perspective. So the history of the Casablanca. Casablanca was built on the site of an ancient city called Anfa. Anfa, it means in English hill, because the topography of Casablanca, it's composed of many hills. It was called the Anfa, an ancient Berber city found in the 10th century before AD. And there is two main steps in the history of Casablanca. The first one is in the 5th century when it was destructed by the Portuguese. And the second one is in the 8th century when it was rebuilt by the Sultan Sidi Muhammad bin Abdullah. And he named it Casablanca, which it means in English, the White House, in Arab, Ad-Dar al-Bayda, because they built a White House and they call it Ad-Dar al-Bayda, Casablanca. So the study context. First thing, Casablanca is my city. I was born and raised and I still live in Casablanca. The second one is the failure of Casablanca Smart City project. This project was launched in 2013 and it's not, and it's a failure until today. There is a rapid urbanization scale and increase in demand for housing. And it's also in the framework of my doctoral thesis because I'm a PhD student. The study period in order to analyze the urbanization and the urban growth and sprawl, we do a multi-date analysis. We take many pictures of Casablanca. We start in 1986 and end in 2019. And from this period, we seen how the city evolved. And there is also the change in the urban morphology of the Casablanca that starts in the 80s. And the population growth and the rural exodus that is mainly caused by the work opportunity in the city. And also there is a drought because Morocco know a drought every 10 years. So people from rural side or rural areas came to the city in order to find a job and to live. So this is the study area. Casablanca is Atlantic city, and Casablanca is the economic and financial powerhouse of the Moroccan economy. It's holding more than 60% of the country foreign trade and accounts for 30% of the GDP. Casablanca is a city with 3.5 million inhabitants and more than 4.3 inhabitants in all the agglomeration. So now we'll move to the Casablanca Smart City project. In 2013, the city of Casablanca presented its Smart City project during the Casablanca Smart City Expo. The project was awarded by the American Institute of Electrical and Electronic Engineering the label of the Smart City Initiative. And it's still called, until this day, the Smart City Initiative 2. It's based on a concept of mixing between smart, frugal, social, and sustainable. And this is important. This is the way that Morocco or Casablanca, the decider, see how they can realize their smart city project. It's by being smart and being frugal. That's mean using what we have in our hand and not looking for a lot of depends in terms of money, and social and also sustainable. The city that and in this vision and in this conception, the city places citizens at the center of the transformation process by creating a public partnership, private population. That's mean there is 4 parts in this vision. Like we can see here in this illustration, the 4P or the vision is that the smart city project will include partnership. That's mean smart city project funding, international and national partnership, and shared value. That's mean that we will use and benefit from the experience from other and found from international and national fund. There is the private sector. Everyone knows the private sector, and the private sector mainly intervene in the transport, the facility, the energy, all the sectors that the country or the government is privatizing, you know. And the public part is the governance, the wilaya of Casablanca, or the region of Casablanca, or the ministries of its public enterprise administration. So the governance part of it, and the people, the civil society, independent experience, and citizen association. So before we move to the study in about the urbanization and the rapid and the urban growth and sprawl, we have to understand few things in the Casablanca Smart City project. Is that this project came in 2013 in order to facilitate and to make better the life of the citizen of Casablanca, and to be smart in the way we deal with everyday challenges. And I want to show how this failed, because for me it's a failure in this project, because what was planned was not executed, and thankfully or fortunately we know the reasons and we can adjust in the future. So in the spatial analysis, we use 4 satellite images, 3 from Landsat TM, 1 from 1986, 1996, 2007, and 1 from Sentinel-2 image 1982. We also use aerial topographic map, and the demographic map of Morocco, and the urban development plan of Casablanca, and also field observation. That's the data, the satellite imagery, that's before any process or pre-processing was made in them. And we can notice even in that the city of Casablanca, between the start of the period and the end of the period, it gets bigger. So the methodology that we use for the spatial treatment, it's a well-known one, normal one. It's not something revolutionary. It's based on, we took the images and we do some correction, the pre-processing, and then we do some classification and digitalization, and then we can have our change detection results and card and map. So this is the result of the classification. What is new in this work? It's that we separate the class of built-up into 3 underclasses. We have in red the highly dense built-up, in yellow in gray the dense built-up, and in yellow the low dense built-up. So What is the difference between highly dense and slow dense? The highly dense built up, it's a lot of building. We have a lack of vegetation and lack of green space between them. And the dense, it's also the same thing, but we got some vegetation. And low dense, it's built up and vegetation, built up and gardens. And in green, this is the forests and green space, and in brown, it's the bare soil. And as we can see, the importance of this difference between the built up. Why? Because, you know, for example, between 1996 and 86 and 80 and 96 and 2007, the city didn't grow much in terms of superficie or surface, but it changed some low dense built up, changed to highly dense built up and dense built up. And because, you know, we have one floor built up, we demolish them and we built a high floor built up. And then when the city space is full and saturated, we start moving to the suburbs. And that's what's happened in the 2019. And we can see the distance between the forest and the city. Now it's mainly, for example, the forest is inside the city. And we can also
2 minutes. Sorry
Yes.
for the interruption.
Oh, thank you. So here we have some numbers. We can see how the city changed from 1986 to 2019. It's mainly the bare soil who changed much in this, and we can also see that the built up, also we have more built up areas, more built up land. So that's the result in number, how the low dense and all chap build up are grown by more than 60,000 hectares, more than 144%. The green space, they went down by 4.5, and the forest went down by 31.4. So as a result, the rapid scale of urbanization and the urban growth and sprawl are impacting the city by the public transportation, because this new built up need transport, the waste management, the accessibility to public services, health, education, and public administration. And it also creates a major problem in terms of security and safety of citizens in these areas. And also it brings us back to discussion of the sustainability of the city. Now we have to talk about sustainability more than before being smart. We have to be sustainable. As conclusion, for me, the reasons of the failure of the smart city projects are the same reason of its success. It's the law. We have to reinforce it, to empower it, and the decision maker. We have to change the vision of this decision maker, and also the citizens. And for me, it's the most important one, because the behavior of the citizens, it must change toward a smart citizens and sustainable citizens, and not a citizen who is always waiting for others to do service for him and offer him jobs and opportunities. And thank you for your attention.
Thank you for your presentation. Are there any questions?
Thank you very much for the presentation. I have one question. So when you were showing the evolution, the maps with the evolution of the population density, I was wondering if that is, well, that's usually a consequence of economical growth or population growth that we've been having throughout different countries in the world. I wonder, in your opinion, if this high density isn't just a consequence again of this population growth, or you think it's actually some factor or consequence of this smart city project implementation in the city?
Yes, I understand what you said. It's true. The urbanization, the main factor are economic growth and population exodus. But in 2013, to put you in the context, Morocco said that the best way to deal with this urbanization or the rapid scale of urbanization is to implement a smart city project. And they choose the city of Casablanca because it's the main city, not only in Morocco, but in North Africa. And they were very serious about this project. But then this project failed because we have the reality of the field. We have some corruption, some laws that are not applied. So people who are dealing with the urban strategies and urban decision making, they choose the option where they will get more money from guys who will build the city, and they don't care about the sustainability. For example, in 2010, the company who was dealing with the waste management, domestic waste management, they say that the city was more sustainable in 2010 than 2020. You know, in 10 years, we go back because the city grows too much and the new suburbs are not well equipped and they are not modern. And that's why I say in the end, the reason of the failure are the same reason of the succeed of the project, because we have to be more serious about that. And I don't know if you see the last ranking of the smart cities in the world and in the developing country, Casablanca was not listed. And it was like a shock for the people here and the decision maker. But in reality, it was something obvious because they act in a different dimension than smart city.
Thank you.
Okay, yeah, thank you for the very interesting presentation. I also want to ask this focus on smart city projects. I think that might be a good opportunity for the future to have a better control on expanding cities. And that's my question, or now my question comes, what can a smart city concepts or approaches, what can they provide to improve this situation of expanding cities globally? Now, that's a phenomenon we have globally in all countries, or many countries. We have a strong, we have growing cities, and what can the smart city approach provide to reduce this problem?
Thank you for your question, and this is a good question and very important one. Why? Because the developing country or the like African country, they have to benefit from the experience of the other countries that already had smart city implemented in their city. But the main problem that we have is that the politician in this country, they don't see the benefits of the project as you see it and we see it. They see how much money they can make behind it. For example, for me in Casablanca, we can be a smart city, but we have to have our own concept in Casablanca, because we don't have, for example, the money of the Gulf country or the North American country. We have to use our resources. That's how we can benefit from smart city. First thing, as you said, we have to stop the urban growth and sprawl. For example, we will say in this 2-year window, we will stop the building, and we'll try to assess what we have and try to make decision and find solution for what we have. But if you don't stop the hemorrhage and you keep building new houses that are not respecting the law, the respecting the environment, the climate change, and all that stuff that we are talking about nowadays, how this smart city project can change, can affect us? I think it will not have a great impact because we do not put the right condition for it to work.
Okay, thank you very much. It was a good explanation. So in my understanding, first we have to solve the political issues.
Yes, sir.
And in the second step, then we can implement new approaches of smart city.
Yes, and
Yeah.
sorry, I didn't mention one part, and it's also important. It's us as citizens, we have to change our behavior, because we were used to this old-fashioned politics and old-fashioned way to deal with our government. Today, we are talking for more interaction, more inclusive politics. So also for me as citizen, I have to change. I have to be smart one too. I have to take my responsibilities too. And that's also a step that came with education. And we have also to focus on that.
Yeah, thank you. Because it's not only a problem of underdeveloped countries or countries in Africa or Asia. It's also a huge problem in Europe. I know it from my area in Munich. We have also the problem, it's overcrowded now, and it's getting even more overcrowded. And we need new concepts of smart cities. But you are absolutely right, it's also a political issue.
Yes, sir.
I have to interrupt you both now because we have limited time for questions. Yeah. But thank you very much for the questions and comments, of course. Thank you again.
Thank all of you, and I appreciate that, and see you in next occasion, inshallah.
Okay, thank you. Now we will try to continue with Dr. Yusuf Ibnata, who already started his presentation. Are you available? Yes, Dr. Yusuf, you can continue your presentation.
Sorry, the connection is so bad today.
Okay, now we can see your screen.
Okay. Okay. This table presents the major constraints of indoor positioning system. For example, pedestrian can suffer from instability. For Wi-Fi based RSS suffer for Bluetooth suffer from multipath penetration effects, card constraint. For radio frequency identification suffer from penetration effect. For triangulation approaches suffer from multipath instability, penetration effect, signal interference, and card constraint. For UWB system suffer from penetration effect, signal interference, and for vision or light-based localization suffer from light effects, or and the card constraint. For ZP protocol suffer from instability, penetration effects. For ultrasound suffer from multipath instability and penetration effect. the evaluation criteria for an indoor positioning system, among the criteria for choosing a high performance system, precision, energy consumption, costs, easy to deploy, stability, response time, adaptation to changes in the environment, adaptation to the heterogeneity of devices. For the exposure of the different indoor classes, in this paper, we divide the indoor positioning approaches into 6 categories. First one, Wi-Fi or Bluetooth. Pedestrian approaches, based approaches, triangulation and trilateration based approaches, approaches of identification by communication algorithm, localization by vision, and multimodal location. For the first one, this category is divided into subcategories. First one with site survey and other without site survey. For the first one, mobile send data to the system in purpose to build the database offline. And with the comparison between online measurement and offline measurement, you can estimate the location of user. For the last one, this subcategory, the user send the data to the system in purpose to build automatically the database online, and then the floor plane. With the comparison between online measurement and floor plane, we can estimate the location of passengers. For example, TILOC. In TILOC, the other applied the robust principal component analysis to form the fingerprint offline online to reduce the noise of speed peaks. TILOC still uses the weighted calf near neighbor algorithm to reduce the client location. The simulation error is less than 3 meters. For semantic Islam, in this approach, the other uses Islam technique to form the database automatically. Therefore, the other merged all inertial sensors, such as accelerometer, gyroscope, compass with Wi-Fi to improve the system. The other used particle filter. The average accuracy is 0.53 meter. For pedestrian hydrokinine, this category uses the inertial measurement from sensor such as accelerometer, gyroscope, magnetometer, and barometer. For example, the accelerometer is used to detect the steep length. The gyroscope is used to detect the hidden angle, and then estimate the location. For the
I guess we still have the technical issues. Okay.
Sorry. Can you see the screen?
Yes, we can.
For the magnetometer is also used with some SIP, offline database creation, online measurement of magnetic field values. Compare the two phases, online, offline of magnetic field, and then determine the client positioning. For the barometer is used to detect the floor changes. For example, high accuracy localization and the calibration for 5 indoor magnetic system. Other used magnetic cores, which certainly form the link between all terrestrial magnetic field and positioning. The average error of distance is between 0.3 meter to 0. And the angle error is between 2.8 degree to 9.7 degree. For triangulation and trilateration based approach, this category use some mathematical tools such as angle of arrival, angle difference of arrival, time of arrival. which virtual unsure used to solve the problem of hair loss and the extended Kalman filter to improve accuracy of mapping with the time of arrival. We can estimate the position of user. For identification by communication tag reader, this category
I'm sorry for the interruption.
It's
Can you just
also used
conclude with
in
your
indoor
remarks?
positioning, either what?
Can you just conclude with your remarks? We just have a minute left to complete the presentation. Are you able to hear me?
I hear you. Yes.
Yes, please.
Can you see the screen now?
Yes, yes. Please continue. Faster, please.
Okay. For the identification by yes, okay. For the identification by communication, radio frequency identification, near field communication, and some smart box under the name of EVCAR. For the millimeter wave screen for passive RFID tag localization system, investigated the possibility of identifying and locating passive tag by adopting a single millimeter wave RFID using a beam steering technique. For the localization by vision, this category is divided into two subcategories. First one use visual fingerprint, and last one use the image video processing. For the first one is used with some steps, create offline database of image videos, capturing images videos online, compare the two online databases, and determine the passenger positioning. Wi-Fi use the first category to estimate the location of user. The max error of Wi-Fi is 60 centimeter. For the multimodal location, this category merges one type of localization system in purpose to obtain a high performance, a high quality. For example, Wi-Fi. For example, Wi-Fi combined the inertial.
I think, Mohammed, we can move on to the next presentation now. We're running short of time.
Yeah. Yeah.
You can just.
Sorry, Dr. Yusuf, but we're running short time, and we still have the technical issues. So
just 2 minutes.
Okay. If you can conclude.
This table present evaluation of indoor positioning system. You can remark that the choice of a high performance system is not depend only to accuracy, but there are many criteria which influence his quality. For the future work, we will study the qualities and shortcomings of the UWB system. We will elaborate fingerprint RSS based on you don't always ensure the good quality of the system, but there are other tools that determine their performance. For this reason, we are not talking about localization, but only about the goal of localization. Because if we lose the money and time to provide a few features that will be usable in practice and that will not change the quality of the system, this is not science. Thank you for your attention. I'm sorry for this bad connection.
Thank you. Thank you again for the presentation. Are there any questions?
I hear you if you are in. Okay, sorry.
I guess one interesting thing that it's just a comment, probably something, I'm not sure if it's very into the domain or not, because this is not an area of my expertise, but one interesting thing would be when some sensors fail, or one sensor indicates one position and another sensor indicates another position, how can we resolve these conflicts between the sensors? So I'm not sure if this is connected to your domain of research, but I think it would be interesting questions related to the topic.
Thank you.
Thank you for the comments. Are there any more questions? Then we will move on to Dr. Katarina Moreira will present spatio-temporal causal relations at urban road networks, Granger causality-based networks as an insight to urban traffic dynamics. The floor is yours.
I suppose you can hear me and you can see my screen.
Yeah, we can hear and see the screen.
Okay. Hello to everyone. Greetings from Thessaloniki and Greece. Just a very short overview of the core team work for the current paper. Of course, the team at the background, as always, is even wider with the upgrades we are doing. My name is Katarina Moreira, and I'm a transport engineer working for the Hellenic Institute of Transport, which is part of Center for Research and Technology, LAS. The rest members of the core team are Professor Theodoros Karakassidis at Physics Departments in University of Thessaloniki, Greece, Dr. George Efantopoulou, his Deputy Director, and Dr. Maria Morfoulaki, Operational Scientist A. Just to note that with the exception of Professor Karakassidis, who injected and inspired us from his experience on physics science, indeed traffic is similarly enough to fluids, we, the women of the core team, are transport engineers trying to get knowledge from the abundance of data collected today regarding urban traffic. So, what we will present you today is the baby development stage, let's say, of what we are trying to automate. So, the title of the work we are doing, we're going to briefly present you, is Spatiotemporal Causal Relations at Urban Road Networks, Granger Causality-Based Networks as an insight to urban traffic dynamics. Yes, urban road traffic is a complex phenomenon, or to state better, a complex dynamic phenomenon. The gradual structure or even unstructured development of cities has increased the complexity of urban functions, part of which is the urban transport network and what we call urban traffic. Urban transportation is characterized by inherent complexity that increases with the increase of city size. And furthermore, the structure of the road network, the socioeconomic factors, the weather effects, traffic management schemes, trip purpose, selected mode, trip distribution, travel time and cost of all alternative modes of transport. And of course, the traveler behavior, when we talk about behavior, we talk inherently for systems complexity, adds on the complexity of the system that we are examining. Urban traffic is also adaptively a non-static phenomenon, presenting variations over both space and time. Short-term variations that are caused by delays in intersection and maneuvers for parking and other needs of road users. Daily variations with peaks and off-peak hours. Weekly variation, we have different profiles in typical weekdays, on Saturday, on Sunday. Long-term variations that are variations over the years that are caused and affected by socio-demographic and global trends. And another, of course, very, very recent situation as what we call shock variations in our research, as the one of the pandemic we are living that has fallen down all the traffic situation here. changing over time and space, urban road is in reality a spatiotemporal phenomenon for which today we collect spatiotemporal databases. The databases host data collected across both space and times that describe traffic in particular locations and over different periods of time. So what do we need to understand? We have data. Aren't we fine with that? Are the data enough for engineers and city planners? Of course not. Not all of us are data analysts, and probably we don't need to be. What is needed is the intermediate step to translate the data into useful insight and then feed again an analysis procedure. In our attempt, we try to find causality in the databases that in the next steps of the research will be injected into big traffic data analysis. In other words, we wanted to overpass a black box, let's say, and find out which are the causal relationships among road paths and in which degree and how does this affect change over the different traffic states from a congested to uncongested situation and so on. Our case study area is part of the road network of the wider area of Thessaloniki. It's the second largest city in Greece. We have highly dependence on private vehicle use. The traffic time series we use for the current work analysis are based on taxi GPS data. These data are being elaborated by the Hellenic Institute of Transport in the framework of a living lab that we have, and it's called Thessaloniki Smart Mobility Living Lab. The data sets come from a fleet of in total 1,200 taxis circulating and generating pulses every 6 or 10 seconds, depending on their speed. The number of timestamps proceeded for the current analysis is approximately 14 million. We refer to a whole semester period, the first semester of 2017. Map matching of timestamps and travel time calculation per road path per quarter of day took place. And the road paths that we have examined can be found in this slide. What we did, we calculated correlation and time lags among the time series per road path. We calculated causality, namely Granger causality. We use the Granger causality notion, and we transformed them to what we call knowledge graph, a visualization necessary for decision making, and we can support then traffic management schemes. Not to stack very much on the questions, but just to say that the MATLAB multivariate Granger causality toolbox was used, and of course we had some descriptive statistics and SPSS. And we then developed causal graphs based on the adjacency matrix, where in the current work, the nodes of the matrix are the road paths, and the leaks are representing what we found before, the causality. No, it's not changing. Yes. Coming to the results, we achieved a good insight from the traffic management perspective. The results of the cross-correlation and causality is summarized in the current slide. The interpretation of the results, among others, revealed significant remarks, as for example, where high causality among which roads is found and on which time lag, so we can understand where to intervene if an event appears on one road path. We found interesting the relations that exist even in non-consequent parallel road paths. So we understand that the complexity of the transport network is much more than the closely neighboring road paths. We identified also the most pivotal parts of the network, so we know that there we should intervene. And afterwards, as I said before, by exploiting the graph theory, the causality matrix is converted to a causality network that is easily understandable. And we need it because we are supporting the city planning, city mobility planning, and not just the city mobility planning, but the sustainable mobility planning, the transit to a smart, sustainable era. And we want to justify traffic management schemes in order to ban from our cities the car. This is the ultimate scope. Concluding, we can say that the results seem encouraging from the combined exploitation of multivariate time series and graph theory for the transport sector. Our outputs is not a decision support system, but can be a building block of it. in the wider area of traffic planning and management. Gradual causality can also be found among different variables. We can also include in our examination other variables, as I said at the beginning, the weather effects and the topological structure of the network. The transfer of the components of the analysis at different levels, for example, from the urban road that we did to an interurban road network is also possible. And more easy, to say, because the interurban road network traffic is more easily understandable than the urban road one. The current analysis was made on average travel time series from a large period, as I said, of one semester, which can give a grand picture of the urban transport performance, what we call recurrent urban traffic. We highly support that the whole analysis should be undertaken in frequent basis in order to take case-specific results. And since the complexity of urban transport system is high, we cannot just stack on one picture of the road network. And the next step is the automation of this procedure, and we will test data aggregation levels in order to compare results from general network trends that we have found to path relations for case events. Thank you very much. And it was a pleasure, just to say, it's my need to express that it was a pleasure to be part of this conference and listen to such interesting cases that I'm not aware of from many presentations, but it's interesting, the brainstorming give us ideas. Thanks a lot.
Thank you for the presentation. Any questions?
Thank you very much for your presentation. I'm very impressed by how you put together all of these concepts. So when I learned about grandeur causality, it was under economics, and now seeing it for applying it for traffic management, I was really curious and impressed and looking forward for this talk as well. I have one question. So you basically were able to infer causality from observational data. So the question, yeah, you were going to add something.
No.
Sorry.
Yes.
So the question that I have is, you made all this analysis and you were able to extract this causal network. So you identified what are the main paths that cause the traffic jams, or so if you were in terms of decision support system, so it's not enough to identify the what, we need to also understand the why, so we can also take actions in order to try to solve this problem. And again, we can come up again with variables like the density of the population is increasing as well. So of course we have more people on the roads, but in your opinion, what can then be done to then ease these traffic paths that are causing so much density in the roads?
As you said, yes, it was also a very new thing for us to take the causality from the economy sector, because time series mostly apply in the economy sector. But we have found it also in neurology sectors, and then we try to transform it in a case for transport, and we show that the results have a meaning also there, as you said. What we think now, we take this. This is a building block, as I said, for a decision support system. We are trying now to combine it with transportation models and see how this propagation of traffic can be stopped. They are not paths that they produce traffic jams. They are paths that something happens there and the traffic is propagated at the next roads. So what we need to understand now is if closing all this pivotal for the network paths, for example, in order to allocate it to the pedestrians and to the cyclists, if this can be viable. Or if we close an arterial of a blood arterial of the system of the city. So no, it's the starting point, I think.
Maybe something that can help with that answer is trying to find locations also in the same country, because it's the same culture, where you have more cycling lanes and see if that actually helped reducing traffic. Because again, it's also a cultural aspect. Southern Europeans, we don't use bike that much. We use more the car than, for instance, in Northern Europe. So maybe our counterfactual analysis could also maybe give you more insights of the why some things are causing the jams, and could help you provide recommendations or better recommendations to your clients. Just putting some things on the table, not sure if it's helpful, but I really found this very interesting. Thank you.
Thanks a lot for this idea. We are also trying to incorporate some issues of interaction with the citizens in order to understand what's going on. And we are trying also in some projects that we have to apply engagement techniques in order to make them part of this planning procedure, because as we said, it's smart sustainable, and the smart is more for the people and then for exploiting ICT results. So yes, probably it's a very good idea to see how we can go on with issues like that.
Thank you.
Thanks a lot.
Thank you. Thank you for your comments. There is a question in the chat forum if the presenter can reply, because we are very short on time. So we will move on to the next presenter, Dr. David Ebo Adipon Yamoa will present Cloud Accountability Method towards Accountable Cloud Service Level Agreements. The floor is yours. You can start your
Thank you very much, Mohammed. Thank you very much, yes. So my name is David Ebo Ajipon Yamwa, a lecturer at Ashesi University in Ghana. And this morning I'll be sharing with you my research, which attempts to situate the cloud in such a way that the service level agreements are deemed to be reasonably accountable. And this is captured through a cloud accountability method. Okay, so I'll just begin with the motivation, go through the proposed approach, evaluation, and then capture the summary as a block. Cloud computing is quite promising in the sense that businesses are able to gain several benefits, such as providing services across the globe, and then also doing this at a reduced cost, which is quite a good thing. The challenge here is that inherently to its nature, there is rapid evolution of its topology because different servers, network equipment are changed rapidly. Now, what is the consequence? The consequence is that it compromises the services because servers may fail, network connectivity may fail, and that will result in a service promised by a cloud service provider to a client not being achieved. Obviously, it affects accountability. So in our literature review, we identified some very salient points made by other researchers. The point is that lack of customer trust, because they think that the cloud service providers are not being very transparent to them. They also often say that weak service level agreement, it's often not very grounded. It's very, should I say, you can't bring the cloud service providers to task based on the service level agreement. There's a perceived lack of reliability, and there's a need for an independent quality assurance body. Yeah. So in further increase accountability on the cloud, there's a concept called cloud accountability that's introduced. Now, in recent times, there's a concept captured by digital forensics model, which is facilitated by a standard from the US National Institute of Standards and Technology. And it uses virtual machine introspection to achieve this, to collect data to prove how accountable a cloud service provider has been. Now, there's another classification of research in this particular area, which goes in to look into trust assurance. And then this classified further into 3 other areas. So there's reputation-based trust, then there's trust assured through the service level agreement verification. Then the final one is the evidence-based trust. Now, in recent times, these 2 trends, cloud accountability and trust assurance, are merging. So it highlights more on the evidence-based trust by adopting often sociology-based models with stochastic approaches like the Bayesian cognitive model and then fuzzy model to emphasize how accountable a cloud service provider has been. Now, it beats our mind as we looked at the challenges posed by other researchers for cloud service environments. We realize that it affects both reliability and availability of the service provided by the cloud service providers. So we frame a question that, can a cloud accountability method be used to meaningfully assure cloud dependability of deployed systems? So the dependability metrics in focus is for reliability as well as availability. Now, how do we achieve this? We set objectives. The first one is that we will need to be able to demonstrate that this proposed accountability method can be applied to a test bed. Now, in the past research work, I introduced an architecture called a reactive architecture, which is already deployed on the cloud, Amazon Web Service, Elastic Cloud Compute environment. Then we go on to the second objective, which would attempt to conduct an evidence-based trust analysis. Of course, finding a way to use some stochastic approaches, also finding ways of getting evidence, basically, to support sort of an allegation or to know whether cloud environment has been transparent in terms of accountability or not. Then the final one is to be able to quantify the experience of the client. So when I use, assuming a client uses a cloud environment for 2 years, can they be able to say that they've made a good investment in the cloud environment or not? This is captured with a concept called a net present value, which is an economic sort of operation. So I mentioned earlier that we have a previous work, which is the reactive architecture, which is essentially made up of 5 components. I'll just simply mention their names: system engineering toolbox, shared architecture, shared artifact repository. We have a reactive middleware which binds them, and then there is the cloud accountability system, which attempts to introspect these components. There's the 5th component is a formal decomposition system, which I'm not allowed to include in here. Okay, so the cloud accountability method is presented as a 16-step methodology. Reading this will take forever, so if you bear with me, I've presented a model to capture its operational use. So if we begin from down here, sorry, where point 1 is, so it captures the cloud agent, which can be the owner of the cloud environment, a cloud service provider. It can also be users like ourselves, researchers, developers. We also have regulators. If they are regulators, they are the cloud agents. So we get access to the cloud platform, 1, through the service level agreement obtained through the hypervisor of the cloud platform. Here we are using 2 main sources. One is based on the API from the cloud service provider saying that, you know what, this is how the cloud platform has been behaving when you deploy the system, as well as also connect hooks using a process called virtual machine introspection based on the digital forensic model standard that was highlighted earlier. So we use 2 different sources of information, one provided by the cloud service provider, and then the one provided by our proposed system, which is collected through an evidence collector, of course. In this case, we are focusing, as I mentioned, the availability and reliability of the cloud platform. There is an auditor component, which decides whether there has been an infringement or a violation of the service level agreement, which would then trigger a notification by a reactive middleware to the agent. Now realize that every activity going on based on the interactions of the system on the cloud environment is logged into a login system. So that will be the focal point for evidence generation for the users. Now, more specifically, if we go to the test bed, going to the evaluation of our system, as I mentioned, we are using the Amazon Web Service, Elastic Cloud Compute to create our test bed. For the reactive architecture, we had 5 components, the various components, including the monitor, the monitoring component, which is the VMI monitor. Now, one thing that I need to point out is that we have deployed the reactive architecture in Ireland. Now, the closest, what we call the availability zone, the geographical location closest to Ghana, and that maintains a reasonable level of connectivity, is situated in Ireland. So in Ireland, there are other centers for the service for cloud. Here, we realize that we have detached the monitor from the other components of reactive architecture, which is in the availability zone, EU West 1C, that's the second point. Then every other component of our reactive architecture is situated in the availability zone, EU West 1B. Now we do the introspection over a period of 3 hours. The reason being that paying for this environment, which is a reserved instance on Amazon Web Service, is quite costly. Now this environment cost us close to over $2,000, sorry about that. And each instance is run as an Ubuntu 16.04 version, and has 2 micro instances, with each having 1 gigabyte of memory, and each dedicated 1 virtual CPU using SSD as our storage unit. So now let's look at how we then undertake this process, guided by the forensic process model. Now in the model, it determines 4 different phases: collection, where we collect our data, where we then examine them, analyze them, and then we report on what we have. So remember the 16-step methodology provided by our research, we classify them accordingly. So with regards to the collection, as I mentioned earlier, we have 2 main sources of our data. We are collecting data through the Amazon Web Service CloudWatch API, of course, owned by Amazon Web Service. We are collecting what they are telling us. Then we are also doing our own introspection in the background using the virtual machine introspection approach. Technology that we used here is the libVMI. Now, the set of metrics collected here are provided, as you can see, but more so, these are classified according to the mean time to failure, mean time before failure, mean time to recovery. And you know that this is the basis for computing reliability and availability. Okay.
We still have 2 minutes.
Okay, I'll try and wrap up. Thank you very much. So the data that we collected are, as you see, in 2 phases. The one to my left is the one collected from the cloud API. Then the one to my right is, the one to my left is the one collected through the virtual machine introspection. The one to my right is for the API provided by Amazon Web Service. But then I highlight 2 things in red. There are points where we classify, I think in our paper, we give more definition as to why we say that this is on an uncompleted service, or a service that was not delivered to the user. And this was captured at 12:15 on the virtual machine, which is responsible for the reactive middleware. And it's captured on both sides in our data. We then plot this basically by saying that if a violation is spotted, we just assign a -1 to it. If there's no violation spotted, we assign 1 to it. So realize that for the 2 sources of our data, they all have a dip around the 2:15 period that we mentioned. That's a very simplistic version of the representation of our operation. However, we go on to provide a stochastic assessment using a Markov chain simulation to indicate the various transitions of the states of our system. Unfortunately, we don't have much time, so I wouldn't be able to go into detail of this transition. As I mentioned earlier, we are able to capture the cost of that failure at 12:15. And here we assess it by saying that using net present value, the user in the 3-hour period of introspection would run a loss of almost $65 based on the NPV. So this is just a period of 3 hours, and we've been able to identify such a loss in this case. Now, in summary, we are saying that bigger evidence log is provided to the client. As you can see, all of these diagrams and all of these data are provided to the client as an XML document. We also then compare our work for the sake of making sure that we are not limiting our work to a benchmark, which is a cloud benchmark, and they conducted their work in 46 minutes. So this is just to prove that even for the 3-hour introspection, it is reasonable enough to depend on it and then make some conclusions based on that. Using the nines of availability, we are saying that for this work, we identify that 94.828 availability was assured as against the promised in the service level agreement of Amazon Web Service, which was 99.9%. So there's actually a loss in here. Then in terms of reliability, which is not provided at all in Amazon Web Service level agreement, we were able to identify the reliability was 0.2294, which is not very promising to a user. Now, what have we done so far? We make 2 contributions. We are saying that we're able to demonstrate cloud accountability by applying a novel method for assuring cloud dependability to a reactive architecture, which is the deployment environment. Then we go on to say that we're able to provide some evidence, which also includes some stochastic analysis based on Markov chains to this deploy system. Then the contribution here is that we contribute these two contributions meet the 3 objectives that were highlighted earlier. And then we even go further to say that there is a quantification of the loss in this case. Then finally, we are saying that to our research question, based on the evidence that we provided, we think we are convinced that we've been able to sufficiently provide a meaningful assurance to the cloud user based on the dependability, which is availability and reliability. So thank you very much for your time. Thank you, and I'm happy to take questions.
Thank you. Thank you for your presentation. Any questions?
Thank you very much. I'm just wondering, so you're studying here about accountability, and you referred about to trust, the importance of trust, how to promote that. Have you, with your approach, can your approach provide any directions on how it can increase any levels of trust in the system?
So that's a very good point. Thank you, Katarina. So one thing that came across through our literature review, we assessed 25 other literature. And one of the recurring thing was that, if I am allowed to go back, I'll just go back quickly. The last point that was made here was that the absence of independent quality assurance body. So among other things, they would rather choose to, of course, in the era of fake news and fake fact, people are saying that no matter how you provide your data, it can be either accepted or even criticized. However, if there's an independent quality assurance body, people would have an increased level of trust. And that is non-existent in the cloud environment. So that's something that I hope that people would pick up, and then in the future would have such a body in place. Thank you very much.
Yeah, I agree with you. I think the topic nowadays of trust is an open research question and a very important topic in several domains. But I have one other question for you. So this system that you presented, it's really nice. So have you thought about how it can scale up? Or can it scale up for the bigger systems?
So the good thing is that cloud inherently is scalable. So that's one good thing. The other challenge is that the part where I use the virtual machine introspection approach defined by the digital forensic requires that we place hooks in the various components that we are introspecting. Now, that could be a challenge if there's more systems to place our hooks to get data from. So that's the only perceived challenge that I see. But in terms of our capacity to collect data, process, and give results, I think that is not a challenge at all.
Okay, very interesting. Thank you very much.
Thank you, Katarina. Thank you, Mohammed.
Yes, thank you all. I sincerely thank you all for your presentations for today and for the excellent presentations and contributions in this session, and all our participants for being part of this international congress. I hope the session was informative and knowledgeable as well. All the presenters would be getting their digital certificates through mail within 2 days or 2 working days. Further, all the papers have already been forwarded to Springer. The publication will be live within 4 to 6 months. Kindly cooperate with the team of ICICT 2021. I also thank our session chair, Dr. Katarina Moreira, for chairing this session. A token of appreciation to the chair on behalf of Team ICICT 2021 and Global Knowledge Research Foundation. Thank you for your presence. And now I ask you to turn on your cameras for a quick snapshot of the virtual conference, please. Thank you. Stay safe and take care. Thank you again.
Thank you.
Thank you.
Bye-bye.